record. Okay. So what I mean by policies is, let's use a lot of the analysis that we have been already applying to these different environmental challenges that we have been discussing in the course. And let's think about what is it that is needed so that these externalities are corrected. What is it that we can use as public policy to combat these problems, but from the perspective also of the political economy of the problem. And when I say the political economy of the problem, is that it could be the case that some of these policies are harder to implement when there are power distributions involved that impede some agents to move forward to a Pareto improvement, or there are certain policies that require certain powerful actors, agents, to put their interests on the table and affect the final result. And I'm going to show you a few examples today of this kind of situations and some of the tools that we can use for that from the economic toolbox that we have. Before I do that, let me quickly run a poll of questions of your reading of the chapter, of that particular sections, of those particular sections of the book, and see how much are you comprehending some of these concepts. So let me throw here the poll right now, there. So go ahead and take your time and let me pause here. I will copy and paste these to update the file for the different polling questions that I've been posting in Moodle so that you can check with your answers. But overall, I see some of you missing some of the right answers here. So we'll hopefully with today's class, we can clarify some of these doubts, but I want you to check back with the right answers that I post in Moodle. I don't want to go over the questions right now because of time, because I have barely time to cover what I wanted to cover today, but check that when I post that. Okay, so let me first go to the concept of abatement cost. This is one of the questions. And let me just say that whatever it is that we can do to reduce the levels of externalities that harm part of society is what we would call abatement policies, and the costs associated to those abatement measures are going to be abatement costs. So if we go back to the examples that we were doing before, taking from the examples that Catherine and Jonathan and Max were presenting, we could think of trying to reduce the harms that are created by fracking, either by changing the technology that fracking uses, improving the seismic data recollection to point out where is it that you can cause the least damage possible, and anything that you invest in making that technology less harmful is going to go to the list of abatement costs. Okay, in the case of deforestation and clearing forests, let's say that growing a certain type of animal with a particular technology is causing emissions that create global warming. You all know that cows emit lots of methane, and changing the technology for the feed of these cattle so that they produce less methane, and all the amount of money and effort that you put into changing the technology for feeding these animals to reduce the methane that they can emit is abatement costs, okay? Or using different kinds of animals, or not clearing the forest and growing the animals within forests, which is the whole silvopastoril technologies that exist today, in which you can grow animals without clearing the forest. All these costs of doing that will go into the pile of abatement costs. Okay. In the case of energy production, Kristen's example on energy. So if you are interested in switching from fossil-based energy towards wind energy or solar panels energy, all the investment that you have to make to transfer the technology to move towards those technologies would go into the abatement costs in that example of Catherine's. Okay, so that's important. And I was going to ask you, but I don't want to skip. I want to skip this so that I don't miss what I'm trying to explain in the new models today. Think of an example of abatement policy in your own particular essay. I just mentioned three of you from those examples that you helped me put in the graph when we were analyzing this, with the examples from Catherine and Jonathan and Max, in terms of abatement policies. Implementing a carbon tax is an abatement policy. Investing in solar energy to move away from coal plants is part of an abatement policy. Okay, so that's important. And just think of your particular cases, which are abatement policies that would be interested to think and to analyze, because with the models that we're going to be doing today and Thursday, you can apply this to the particular problem that you are analyzing. And one of the key things about abatement policy and the idea of abatement costs is that we are trying always to achieve cost effectiveness. And when I say cost effectiveness, I mean, how is it that we reach a particular goal at the lowest possible cost to everyone, lowest possible social cost, right? So there are ways of reducing environmental harms, damages, but they all cost something. As economists say, there's no free lunch. And this is a good example in the sense that you will have to give up something if you want to reduce your environmental damages. You have to give up something: money, technology, jobs, something. How much of that is what we're going to be dealing today? How much is too much and how much is good for society in terms of giving up something to implement abatement policies that will maximize social welfare. And for that, and that's the next bullet there, it will depend also on the policymaker preferences. So depending on the person that is leading the design of the policy, that policymaker is going to have different preferences, different weights between, for example, jobs and clean air. So if the policymaker wants to favor jobs because the policymaker was elected by a constituency who is claiming about jobs, it's going to shift the abatement policy towards privileging jobs and probably harming the environment more. But if the policymaker was elected by constituents who were more environmentally biased and concerned, that policymaker may favor increasing environmental quality against losing certain jobs. And that's exactly what we're going to try to do today with this other approach that we have from the text in chapter 20. And for that, I'm going to show you, just as an example, this particular case of the Taranto location in Italy, which is a great example of how difficult this is, but how real it becomes in terms of these types of problems. And this has to do with the problem of bargaining, because if you have to bargain between jobs and environmental quality, you are going to have people who are interested in one or the other one, who are going to put political pressure for the policymaker to shift its decisions towards one side or the other one. And notice, it could be the case, and the Taranto example in Italy is perfect for that purpose, that you have people that at the same time are interested in the jobs that this particular company offer, but at the same time, they are harmed by the damage that the company creates because you live nearby the company. And that creates a more complicated picture. And therefore, the word bargaining becomes so important, because here the problem is who bargains with whom and how you end up in a socially optimum situation. And that's not easy to figure out, okay? And one more policy or approach in terms of policy that we can think of is the case of cap and trade, which was one more of the questions that you had in the polling quiz today. And in that particular case, I'm going to show you few data on the prices of this cap and trade mechanism, in which, as some of you correctly responded in the poll, is a mechanism in which the government emits a number of permits of pollution, a maximum number of permits. Then the government assigns them to people either through an auction or assigning them for whatever criteria the government wants. And then the owners of those permits trade with each other until they find their personal favorite level of pollution and their personal favorite permit number of permits, so that each company, depending on its technology, decides how much to emit for a total number of maximum permits allowed. So you try to cap the level, to put a ceiling on the total level of pollution, and then let below that the agents trade with each other. And we're going to be seeing that model too. And probably by Thursday, we will be talking about the issue of measuring benefits and costs when we don't have market prices to do so directly. And finally, the issue of present versus future generations and the dynamics of sustainability. And for what I want you to read that short piece by Amartya Sen that I posted in Moodle, and that I'm going to incorporate into the discussion next Thursday. So with abatement costs, what I was saying is we need to find out how costly it is to stop the damages, or how much it costs to lower the damages. To what level? We already have seen different models of the optimal level of pollution, right? So with that, we come back to the problem of opportunity cost. What is it that we're giving up to reduce environmental harms? And which is the most cost effective, which is the cheapest way to achieve that particular goal. So for example, the World Health Organization may say, okay, water should be at least at this level of pollution. If you go beyond that in that particular chemical content, it's harmful. Or the same for air pollution. This is the maximum allowed for humans to be able to have a healthy life in terms of particles per million in the atmosphere, or CO2 content, or ozone content, all these different indicators. And then we ask the economic question, which is the cheapest way to get there and not overpass those levels. And in your particular research topics, you can think of all these environmental harms, and therefore you can identify these abatement policies for your case. If it is related to the harms associated with health, with a loss of biodiversity, in terms of loss of productivity for someone, all those are examples in which you can identify the environmental harm and the abatement policy to reduce that harm. And that's the analysis that we're going to be doing. And last time I showed you quickly this graph, which is how interesting technologies today show so much variation. And notice that if we think of these type of solutions, how cheap they are to reduce emissions of CO2 equivalents. The cost in euros per ton of CO2 reduced. You see that it is quite cheap to reduce slash and burn agriculture conversion. And yet it is happening today. The satellites monitoring the Amazonian today, the Amazonian basin, particularly in Colombia and Brazil, are showing today fires all over the place. Stopping those fires would be the most cost-effective way of reducing those emissions of CO2. It is cheap in terms of costs, but politically is very complicated. Among others, because the governments have very weak capacity to get there. It's expensive to bring the troops, the helicopters, to detect, to capture these people, and so on. Okay, but if you keep going down, you will see that certain technologies become a little bit more expensive, and some technologies are quite expensive to reduce that cost of reducing every ton of CO2 equivalent. So retrofitting a gas plant, it's quite expensive. So if you retrofit one of these gas plants or even coal plants here to reduce the CO2 emissions, it would cost somewhere around 50 euros per ton of CO2 reduced. So with that in mind, with that idea based on empirical data that it's out there, we can think of this particular graph in which we have in this axis the environmental quality we want, right? So the more environmental quality we want, the higher we go, and the cost of abating emissions so that we achieve that environmental quality. And the curvature of this graph is quite interesting because notice that it has this concavity. What does this concavity mean? It means, notice that if I think of going from here to here, just that little cost, moving from here to here, notice how much I achieve in terms of environmental quality. You see? Much smaller cost, a lot of gain in environmental quality. Okay? But as I add up, and that's why the cheapest technologies are around here. But as I move up in adding up new technologies to improve environmental quality, they become more and more expensive. So I'm going to go with example from here to here, an equivalent expenditure in money, going this amount of extra abatement costs, this amount of billions of dollars of doing that. And notice that if I go up, how much bang for a buck I get from that is much lower. You see? You see this triangle? I get too little here in gain compared to how much in gain I get here. See what I mean? And that's associated with the concavity of this curve. So as I go towards this direction, technologies become more and more expensive. They become less cost effective in helping me achieve a particular environmental quality. Okay? So with that notion in mind, that there are cheaper technologies to do abatement and costlier technologies to do abatement, then I can think of the next now economic model to think about the preferences of the policymaker, which is one of the main points that I want to convey today. So again, now notice how the axes are flipped 180 degrees in the horizontal axis. So now we are going to think of a, let's call it a frontier. This curve here, I'm going to call a frontier, this curve here, which is associated with what I just said in this previous idea. And I am going to have in the vertical axis the amount of environmental quality that I want, cleaner environment, healthier environment. And in the horizontal axis, I am going to talk about the consumption of goods and services for the economic activity that creates the harm to the environment. It's going to be a trade-off. So if you remember the first day of class, If we consume, produce, and enjoy more cars, it's good for us, but that will mean a poor environmental quality. Because the more cars we produce and consume, yes, we move to the right in this axis that you see there in the graph, which is the consumption of goods and services, but it reduces the environmental quality because if you remember, the more cars we produced and sold in the market, the more damages to you had to pay in terms of the mitigation and adaptation to climate change. So anything that goes from here in this direction, we are going to call it abatement costs, in the sense that we are sacrificing something to improve the level of environmental quality for society. So in that sense, if you think of the extreme case, which is, let me erase this here, the extreme case, which is here, in which we say, let's have 500 billion euros of consumption of goods and services, which is a proxy for economic progress, right? That's here, the economy working at its top, full steam. And the economy can produce 500 billion euros equivalent in terms of consumption of these goods and services. But at that point, the environmental quality is the poorest, which is at 0. And we want to reach better levels of environmental quality. We want to go up here. We have to give something up. So let's say that we reduce the consumption of goods and services from 500 to 450 so that we achieve this level of 62 of environmental quality. Notice, we increase all this amount of environmental quality by giving up this amount of economic activity measured in terms of the foregone consumption of goods and services. And that's what we would call the abatement costs in this case. What is it that we give up to improve the environmental quality? So we went to this point X, in which we have better environment and lower level of consumption of goods and services. Is that point X the socially ideal? We don't know yet. Because again, that's going to be the problem of the policymaker. What if the policymaker and the constituents of this case want something around here? They just want to give up too much of the economic activity because they value enormously the environmental quality. Or what if this is a community that prefers an economy working full steam, creating a lots of jobs, consumption, and they don't care much about the environment or the consequences to them or the next generations, and they want to be here? That's the next step. And the next step is related to the preferences of the policymaker. And those preferences are reflected in these indifference curves, which have a particular slope. And for matters of making it simple, it's a straight line, meaning that the slope of that blue line that you see there is the rate of substitution. How much this policymaker is interested in giving up one unit of environmental quality? How much is this policymaker interested in giving up economic activity? Right? So if you think, let's put it in one more color, a very pro-environment policymaker, one that was elected with the Green Party, everybody is very pro-environment in that particular place, right? The indifference curves of that one would be more like this. Meaning that they would prefer sacrificing more economic activity in terms of consumption of goods and services in order to gain more of an environmental quality. But if you think, and let's use one more color, let's see, purple. A policymaker that is preferring to favor, let's say, consumption, economic activity, creation of jobs and the like, probably those indifference curves are going to be looking more like this. For this particular guy, for this particular policymaker, and given those indifference curves that you see there in blue, the ideal combination of environmental quality and economic activity measured through the consumption of goods and services is going to be located in point X. So a few annotations on that. The point X gives you the maximum levels of two things that you want. You want environmental quality and you want economic activity measured as a consumption of goods and services. And X is the point where you maximize the satisfaction of the policymaker's preferences that are still feasible. And I say feasible because if you remember, we did this a long time ago. Imagine, for example, this particular point here, and I'm going to call it C. C should give you more satisfaction of what the policymaker wants to achieve. Or if you want to be, and C is still a good example, but let me put one more. Let's say this point here. It's too small here and I can write correctly. Let's say this point C. Notice in point C, you have more environmental quality and more economic activity in terms of consumption of goods and services. What's the problem with point C? Anyone? Anyone wants to jump in? Say that again.
It's impossible to attain based on the feasible set.
Exactly, because it's outside of the feasible set. Of course, it would be nice to have more environment and more economic activity, but it's not feasible, at least with the technology that we have today. Now, point B. Why we don't like point B if point B has more economic activity? Or why do we prefer point X over point B? Anyone? Why is point X better than point B for this policymaker? And for that, yeah, go ahead.
Well, for this policymaker, because he values he or she values the quality of the environment more than the consumption of goods and services.
Yes, and for that, let me give you one more point. Let's call this point here D. Which point gives more satisfaction to this policymaker goals, D or B? Thomas, you're muted.
Oh, we're talking about the policymaker on the bottom.
So we're talking about this
who?
policymaker, this particular policymaker who shows these indifference curves. And I'm asking, which point gives this policymaker more satisfaction, point D or point B?
Honestly, I don't know how you can tell from.
Actually, you're right. It's indifferent because they are on the same indifference curve, right? So B and D gives the same levels of satisfaction to this policymaker, but X gives more satisfaction because X is more further away from the axis origins of the graph. So X is better than D and B, and C is impossible. So at X, this policymaker maximizes the satisfaction of society if one assumes that the policymaker is maximizing the well-being of society because he was elected through a democratic process that is collecting the interest of society. Okay? That doesn't mean that there are particular interest groups that will shift the slope of these indifference curves of the policymaker to make them steeper or flatter, depending on who pushes more. So if you think about Massachusetts, probably the slopes of those graphs are going to be eventually flatter, or at least Western Massachusetts. If we think of Maine, Vermont, New Hampshire, are probably more environmentally concerned constituents who, when they vote, try that their elected officials reflect their preferences. But on the other hand, you could have places like Texas, in which they are more interested in the consumption of goods and services associated with the oil industry and fracking, and therefore they allow fracking and they don't have problems with fracking. But try to bring a fracking project to the Pioneer Valley and tell me the story. How would that go? If someone would come to the UMass campus and say, hey, we want to do fracking right next to the campus, and see what happens. That is going to be reflected in the slope of these indifference curves. So that I want you to think about how we find the optimal policy solution. And in this case, for these particular preferences, how is that in point X, and why it is not point D or B or C? I want you to have that very clear. But also, what political forces are in play that determine the slope of these indifference curves? And for that, because I ran out of time, I am going to send you a link to a short video and couple news notes on this particular case of the Taranto village in Italy, which is a great example of what we are trying to deal here, so that on Thursday we enter into the model of analyzing the bargaining between, let's say, jobs and the environment. So instead of me showing that in class, I'm going to send you the video clip to you so that you watch it before class, and then you have in your head how interesting this particular case in Italy it is, because it's still going on today and very complicated. Okay, so let me stop there, and thank you for coming to class today. So I'll see you guys on Thursday, and please try to watch and read what I'm going to send you about the case of Italy, so that we can move forward in class after you have read that. Okay, so thank you for coming, and I'll see you guys on Thursday. Okay,
Thank you.
bye-bye.